Lesson 20 is all about volumes of different figures, and in 20.1 we're going to look at cylinders. We're going to start with prisms though. So starting at the very top, the volume of a three-dimensional figure or solid is the amount of space inside of that three-dimensional figure. So with a two-dimensional figure like a square, you can find the area, and then with like a three-dimensional figure like a cube, you can find the volume, and the volume is how many cubic units can I fit within that figure. Okay, one type of three-dimensional figure is a prism. And there's just certain rules that kind of make something a prism. So the first one, it has two congruent parallel bases that are polygons. So on the figure at the right, we have two triangular bases that are parallel to each other because they're never going to cross each other. So those are the two that are shaded in blue. One thing to keep in mind is that the base may not necessarily be like the top and the bottom because the polygon could be like sitting on its side or something like that. So it's important to know that the bases are always parallel to each other. And then the second bullet point, the lateral surfaces that are, or they have lateral surfaces that are parallelograms. So if we look at this figure, all of the lateral surfaces are the ones on the sides right now, just because the prism is set on its base. So like that's a parallelogram, this is a parallelogram, and then so is that one in the back as well. So all of the side surfaces or lateral surfaces will be parallelograms. Of course, they may end up being like on top or on bottom, depending on like which way the prism is lying. Okay, moving down here, prisms are typically named after their base. So for example, there could be like a triangular prism. It has triangular bases like the one in this picture, or there could be a rectangular prism, which an example of rectangular prism is down here. So you always name them after their base. And then moving down to the volume of the prism. So volume of prism, the formula is V equals capital B times H. That capital B is important. So like for, you don't need to write this down, but like for the area of a parallelogram, it's lowercase b times H, and that's saying the length of the base times the length of the height. The capital B in this case is referring to the entire area of the base. So it's important to know that that capital B is the area of the base, and how you find that will vary depending on what shape the base is. So for example, for this base is a rectangle, so you would find the area of that base from length times width, and then after you find that area, you'll multiply it by the height of the entire prism. So you find the area of the base and then you multiply by the height of the entire prism. You can technically use that same formula for like finding the volume of the cylinder over here. So I'm going to rewrite it next to, and we're just going to kind of show how it compares to our new formula for the volume of a cylinder. So volume equals base times height. That's for any general prism. And then now for the volume of the cylinder, I know it says V equals pi r squared times height, but let's just approach it as if it were a prism for right now. So if I needed to find the volume of my base of my cylinder, my base is a circle. Or sorry, if I need to find the area of my base of my cylinder, the area is a circle. So the formula for the area of a circle is pi r squared. So that pi r squared is how I find my capital B. So the volume of a cylinder formula is really just taking out that capital B that represents the area of the base and replacing it with the pi r squared, just to make life like a little bit easier so you don't have to go and grab that pi r squared from scratch every single time. So volume of a cylinder, you can use V equals pi r squared times height, where r is going to be the radius and then h is going to be the height. Okay, example 1, use the diameter and the height of a cylinder that are 28 centimeters and 10 centimeters respectively. What is the volume of the cylinder? So to find the volume of the cylinder, we'll use V equals pi r squared times the height. When it gives you the like kind of lengths together and it says respectively, that means like kind of the order that they listed the like parts of the cylinder and the like order that they wrote the values in, it stays consistent. So like it says the diameter and the height, that means they'll give us the diameter first. So the diameter would be 28 centimeters and the height would be 10 centimeters. So diameter is 28 and then height is 10. Okay, so for the, to find the volume of the cylinder, pi is a number. It's not going to be a variable ever. It's just something we leave there. We need the radius and we need the height. So we have the height, but we are given the diameter. So to get the radius from the diameter, we have to take the diameter and divide it by 2. So if we picture a circle, we have our center right here. The radius goes from the center all the way through this, or to the edge of the circle. And then the diameter goes all the way from edge to edge through the center. So the radius is always half of the diameter. So we'll take the diameter and we'll divide it by 2. So we'll do 28 divided by 2, and then that gives us 14 centimeters. So that means that the radius of the base of the cylinder's base, which is a circle, is 14 centimeters. So we'll go ahead and we'll take that 14 and we'll put it in for R, and then we'll take the 10 and we'll put it in for the height. So it'll be V equals pi times 14 squared for radius squared, and then times 10. Okay, so we want to make sure that we kind of follow order of operations correctly. So you would never be able to multiply the 14 and the 10 together first. We would have to simplify exponents first. So I'm actually going to move this over here just so I have a little bit of room to work below it. So order of operations, you would simplify exponents before multiplication. So we're going to find 14 squared first. So 14 squared is 196. So we'll do equals pi times 196 and then times 10. When you have all multiplication, the order that you go in doesn't matter, because multiplication it has a property called the commutative property that says you can reorder it if you want to. That's only if everything is being multiplied. So I'm just going to go ahead and multiply the 196 times 10, because multiplying by 10, you just have to add a 0 to the end of the number. So I'll bring down the pi, and then 196 times 10 is going to be 1,960. And then now I can multiply that 1,960 by pi. So you can use the pi function on your calculator, or you can do times 3.14. So instead of pi, I'm just going to write the 3.14 just in case anybody doesn't have access to a calculator with the pi button. So we'll do 3.14 times 1,960. And then once we multiply those together, that'll give us our final volume. So 3.14 times 1,960 is, let's see. So we'll do V equals 6,154.4. And then they give us the units in the problem, so we want to include it here. So it's in centimeters. I almost forgot I can move this circle out of the way. It's in centimeters. And then when you find the volume of a figure, it's three-dimensional. So it'd be centimeters cubed. And the reason is because we're multiplying the radius squared is 14 centimeters times 14 centimeters. And then times the height is 10 centimeters. So altogether I have 1, 2, 3 centimeters that are being multiplied together to find the volume. So centimeters cubed, or cubic centimeters. Okay, moving down to 20.2. So 20.2 is about pyramids and cones. So a pyramid is a three-dimensional figure that has a polygonal base and 3 or more triangular faces that meet at the point called an apex. Sometimes it's called a vertex. You could see it interchangeable. So it's kind of what you think of when you think of the pyramids in Egypt. That's a pyramid in math as well. So you can see a picture of a pyramid down here. So like prisms, pyramids are named after the shape of their base. So for me, personally, I always got I always had a harder time picking the correct name for a pyramid because it looks like a triangle to me. But for example, this pyramid in the figure, it has a rectangular base. So it would be a rectangular pyramid. And then you can have a pyramid that has a triangular base and it'd be a triangular pyramid. Okay, so the volume of the pyramid, that formula, is V equals 1/3 capital B times H. And then same thing here, that capital B is the area of the base. So depending on what the area of the base is, that like kind of formula and how to find it will change, or depending on what the shape of the base is, the way you find it will change. This is another like rectangular base, so we would find the area by length times width, and then after that we would multiply it by the height of the pyramid. If it was like a triangular base, you would use the area of a triangular, which is either 1/2 base times height, or base times height divided by 2. Okay, and then moving on to a cone. So a cone is created by making a circle and connecting each point on the circle to a point outside of the circle called the apex. So think like it's an ice cream cone, kind of. So volume of cone formula is like really similar to the volume of the period formula, just like how like the volume of the cylinder formula was based off the volume of a prism. So volume of a pyramid is you take like the capital B, the area of the base, and you multiply it by the height, and then you multiply it by 1/3. It's the same thing here. It's just we have the like kind of area of that base already put in there. So it's volume equals 1/3 pi r squared times height. So this pi r squared, that's B, like the capital B, the area of the base. Just kind of has every value in there, so you don't have to go and like kind of remember the area of a circle each time. Okay, example 1, the following cone has a slant height of 9.4 centimeters and a radius of 3.4 centimeters. So we're going to find the volume of it. I don't know why I didn't write that. I'll write it by the time I post the printable version, but we're going to find the volume of it. So we'll use V equals 1/3 pi r squared times height. So probably the hardest volume of a cone formula that you'll see are going to be ones that give you the slant height, and those require a little bit extra work to find the regular height. So the slant height is referring to like the slant of the cone. But the height that we put in the formula is referring from like the apex down to the center of the base. So those are two different values. And then of course the radius is from the center to the outside of the base. Normal radius. Okay, so if you're given the slant height, it actually becomes like a triangle problem before it's a cone problem. So now you'll see like between the radius, the height, and the slant height, I have a right triangle. So I'm just gonna like pull this off to the side just to give us a little bit better visual. So this was my H, this was L, which we used for slant height, and then this was my radius. Okay, so I'm gonna go ahead and just label what we know on here. I'm going to take out the R and the L actually, so I can put those numbers in. So the radius was 3.4. Sorry, it's not quite to scale. And then the slant height, which is, in this case, it's like the hypotenuse of the triangle. The slant height is 9.4. So now I have a right triangle, and you always have a right triangle when you like take the slant height with the regular height and the radius of the cone, so you'll never have to worry about it not being a right triangle. But now I have a right triangle and I'm missing one side of it. So if I'm only missing one side from a right triangle, I use Pythagorean theorem to find the third side, which is a squared plus b squared equals c squared. So the hypotenuse, 9.4, that always has to go in for c. And then the other two sides, those are called legs. Those go in for A and B. So it doesn't matter which is which. So we can put like 3.4 in for A, and then I'm going to put H in for B, and then that's going to help us solve for H. Okay, so 3.4 was going in for A, so it'll become 3.4 squared, plus H is going in for B, so it'll be H squared. We can't forget about the squared on each part. And then equals C squared, so it'll be 9.4 squared. So 3.4 in for A, H in for B. If you wanted to leave it as B, you could. And then 9.4 in for C. Okay, so now remember, it's important to go ahead and square everything before we try to like subtract or anything like that. So we'll do 3.4 squared, which is 11.56, and then plus 4 squared, or sorry, no, I don't know why I said 4 squared, but plus h squared. So 3.4 squared is, like we said, 11.56. Had like a little brain fart there when I was like writing that. And then plus h squared equals 9.4 squared. So we'll do 9.4 squared. Sorry, I'm typing it out on my phone calculator, and it's kind of a pain that way. So 9.4 squared is 88.36. If you ever notice that like a number seems kind of weird, if you just want to make sense of make sure it kind of makes sense in the context, 3.4 is like between 3 and between 3 and 4. So if I were to square each of those, 3 squared is 9 and 4 squared is 16. So 3.4 squared should be between 9 and 16. If it's not, you have a problem. And then same thing with like the 9.4 squared. So 9 is between 9 and 10. So if I square both, that'd be 81 and 100. So 9.4 squared should be between 81 and 100. So if it's not, then you kind of have an issue. And then now that we've gone ahead and squared everything, we can start to focus on getting h by itself. So I want to isolate it. So what I'll do is I want to cancel out that 11.56. So I'm going to subtract it from both sides. So minus 11.56. So these will cancel out. And then I'll bring down the h squared equals, it'll be 88.36 minus 11.56 is 76.8. And then from there, I need to square root that. So I'm trying to get h completely by itself. So in order to cancel out that exponent, I have to square root. So I'm going to square root both sides. If you're using a phone calculator, you have to like unlock it and turn it sideways to be able to use the square root function. So if you take the square root of 76.8, it's going to be a long decimal, so we'll use h and then it's approximately. Let's go to 2 decimal places, so it'll be 8.76. So the height is approximately 8.76, and we'll just leave it there. It doesn't have to be perfect, but that's what we're going to go ahead and put in for the h in our problem now. Okay, so all that just to get kind of like our last variable that we needed. So we know that the radius is 3.4, so we'll go ahead and put that in. And then the height is 8.76. So we'll go ahead and put that in, and then those are all of our unknowns, so we'll be able to find the volume after that. So V equals 1/3 pi, and then times the radius, so 3.4, times the height, so 8.76. And then, like I said before, multiplication is commutative, so you can kind of multiply in whatever order that you want. I am going to save that 1/3 probably till the end though, because multiplying by 1/3 is the same thing as dividing by 3, so that's how I'm going to go about it. So I'm going to go ahead and take out the pi and put in a 3.14 right away. So 3.14 times 3.4 for the radius times 8.76. And then I'm going to multiply all three of these together. So it'll be equals 1/3, and then we'll multiply all those together. So 3.14 times 3.4, and then times 8.76. So all those multiplied together ends up being about 93.52. And then now I can take the 93.52 and multiply it by 1/3. But like I said, like multiplying by 1/3 is the same as dividing by 3, if that makes it easier to put in a calculator. So same as dividing by 3. So we'll do 93.52 divided by 3. So then we end up with the volume is approximately 93.52 divided by 2, or divided by 3, is about 31.17. And then this was given in centimeters as well, and then we found the volume, so it's going to be cubic centimeters. So volume equals 31.17 cubic centimeters. So I know that's a long problem. And then, like I said, the problem that gives you the slant height, these will probably be the like most difficult version of finding the volume of a cone, because you have to find the like regular height, like from the center of the base to the apex, not just the slant height. So if you're given the slant height, you have to use the Pythagorean theorem to find the regular height. 20.3 is finding the volume of spheres. So a sphere is just like a three-dimensional circle, kind of like a globe. If you saw the formula before, I had to fix it. There was a little typo in the exponent. So volume of sphere is V equals 4/3 times pi r cubed, so r to the third power. So in this formula, the only unknown we have is r. So the only number that you need from a sphere in order to be able to find its volume is the radius. So example 1, find the volume of the following sphere. It's kind of dark, so if you can't see it, the radius is 4. Say r equals 4. And then our formula for finding the volume is V equals 4/3 times pi r cubed. And in this case, the radius is 4, so we're going to put a 4 in there for r. So it'll be equals 4/3 times pi times 4 to the third power. So in this problem, we just have multiplication and exponents, so we'll simplify exponents first. So it'll be equals 4/3 times pi, and then 4 to the third power, that means 4 times 4 times 4, which 4 times 4 is 16, and then times the third 4 is 64. So this will be times 64. And then I would like highly recommend thinking of these as like fractions, so like pi over 1, 64 over 1, and then just go ahead and multiply straight across the numerator and straight across the denominator. So we'll do 4 times pi times 64, so it'd be 4 times 3.14, and then times 64. So 4 times pi, or 3.14 times 64, is 803.84. If you use the actual pi button, you probably got a longer decimal, but you can round it the same. And then we'll do over in the denominator, we have just 3 times 1 times 1, so it just ends up being 3. And then now fractions are just like divisions. We just need to divide 803.84 by 3 to get our final volume. So 803.84 divided by 3 is, we're going to round it, so I'm going to change this to approximately for a final answer, 267, and then 0.95. So the volume is approximately 267.95 if we round to 2 decimal places. And this problem doesn't have like specific units, so we'll just write cubic units. So volume is approximately 267.95 cubic units.